Sí, sí. Bueno, está la de inicio de constructo. Vale. Hello, everyone. Let's wait some seconds. To some people maybe are a little bit late. Okay, so let's start. Hello, everyone. I'm Alberto, and I'm a robotics researcher in the Construct. And welcome to the webinar on how to create your own BB-8 robot in Gazebo, part 2. In the part 1, if you were there or if you have seen the video, we explained how to create a basic non-actuated version of BB-8 robot. In this part, the second part of the webinar, we will add a couple of sensors in order to make the robot aware of what's happening in the environment. And also, of course, with this sensor will come some plugins. So let's start. We will be using Gazebo 4. So let's launch simulator. Let's wait some seconds till the simulator is fully loaded. So, okay, so here it is, perfect. Now, let's launch the BB-8 webinar part 2. Perfect. So here we have the robot as it was at the end of the first part of the webinar. Okay. So let's now open the development environment in order to see what we have here. Okay, so we have the three main packages. You will have always you launch a Gazebo simulator in the construct. We will be focusing in this webinar, as in the first webinar, in the description package and a little bit also in the Gazebo package. So let's open the description package. And here we have the robots directory we created in the first webinar, along with the Chakro and the URDF files. Let's open first the URDF file. Okay, let's change it to XML syntax. Perfect. Okay, so here we have the code we added in the first webinar, so the base link, base rotation link with its joint, the base direction link with its joint, and the head link with its joint. Okay, so now let's start the focus of this webinar. First of all, we will add a camera to the robot. And how we will do this? Okay, just the same we did for the head link or the rotation link or the base direction link. We will add a link for the camera to the robot. We give it the name of camera link with some parameters like we'll place it in the origin. This camera will be a box, a tiny box, as you can see. Some inertia. Okay, these are default parameters for a Gazebo simple camera. So don't worry very much about all these values. And also we will add a joint that will be a fixed joint in this case because we don't want the camera to move. And we will link it to the head link. So the camera will be placed in the head by the y-axis, you can see here. Okay, so let's save this file and relaunch the simulation. What we are doing now is just adding physically the camera. What this means that this camera isn't functional at all. It won't give us any data. It's just a physical camera placed in the robot. Okay, we don't see it because it's very small, but the camera is there. For example, if I open the web shell, okay, this is a simple shell, just the same you would have if you launch a shell in your Ubuntu system. And let's type Rox topic list in order to see the topics. You could see some topics, some Gazebo default topics, but we can't see any topic where the camera is publishing on. Okay, so let's move on this tutorial. Let's open again the development environment. And now we will focus in the Chakro file. Okay, let's put again the XML syntax. Okay, here we have all the data we entered in the previous tutorial that are basically friction parameters. Okay, so now what we will do will be to give this camera a function. How we will do this? By adding a plugin to it. Okay. We can add plugins to any URDF model by linking it to, for example, a link, which will be the case of the camera. We can give a plugin also to a joint or even to a wall robot. We will be seeing also this later. In this case, we are linking it to the camera link. This name is important because it has to be the exact same name that you give to the link in the URDF file. So you can see our link of the camera is named camera link. So the name of the Gazebo reference tag must be camera link. Okay, to put a plugin into a URDF model, you need to put it inside the Gazebo tag, as you can see here. Okay, and then here we just put some data for the sensor. We give it a type of camera. We give it a name also. Some update rate, some data about how will be the images. Don't worry much about this because our all default values you can find in Gazebo simple cameras. Okay, so this is where the important part, where we are adding the plugin. Okay, this file name it is linked to the code that will make the camera give data about what it is seeing. Okay. Again, here are some data. For example, we are giving this camera a name of BB-8 head camera. We are making it publish its image data in the topic image raw. Its camera info will be published in the topic camera info. We will see this later. But now let's test. Let's save the file and relaunch the simulation. Now the camera we added in the URDF file will be publishing data into ROS topics. We will see this right now when it loads. Okay, perfect. Let's open again the shell. And if now we type again ROS topic list, well, here we can see that our camera is publishing. For example, we have the camera info topic we saw before, the image raw, where the camera is publishing data about the images it is seeing. For example, let's do a ROS topic echo of this topic to see if it is really publishing. Here we are. This is all the data that of the images that the camera is receiving right now. Okay. Let's stop this. And let's move on. Then XML syntax. Perfect. Now, once we've seen the camera is working correctly, let's add another sensor that would be an IMU sensor. An IMU sensor provides data about the orientation, velocity, and acceleration of the model, the robot in this case. Okay, first of all, we see that here we aren't giving a reference to link it to a URDF model, like we were doing here, that we were linking this plugin to the camera we created in the URDF file. Okay, when you don't specify anything here, it assumes that you are linking it to the robot tag. The robot tag, which you can see here, it's the BB-8 and it's the wall robot. So we are linking this IMU plugin to the wall robot. Okay. Again, inside the Gazebo tag, we put the plugin. This is the file name that is linked to the actual code of the plugin. And again, here we put the topic where we will be publishing the data. In this case, it will be IMU data. Okay. Let's save now this IMU plugin. And again, relaunch the simulation. Perfect. Okay, so now we have an IMU sensor that should give us data about the orientation, velocity, and acceleration of the robot. Let's check this. Okay, so again, let's type ROS topic list. And here it is. We have a new topic named BB-8 IMU data that is publishing the data the IMU sensor is capturing. Okay, let's, for example, see what this is saying. Okay, you can see all at 0, the orientation, angular velocity, and linear acceleration. Obviously, the robot is quiet, so this is normal. Okay, now we've seen the numeric values. Well, first, let's make a quick mention to the Gazebo package. Okay, this package is almost the same that it was in the first part of the webinar, so you don't have to worry much about this. We have the launches, nothing has changed here. And let's have a look to the package XML. Here we have added some dependencies. Not all of them are used in this webinar. For example, the controllers. This will be used in the third part of the webinar. That will be the last part. But for example, we have here the sensor messages package, which defines how are the messages that the sensors are giving. We have also the Gazebo ROS package, which allows Gazebo to interact with ROS. But well, just add these dependencies, and you will be adding the ones you need for this part and the ones you need for the last part of the webinar. Okay. Now, let's keep on going. Okay, we have seen data of the IMU sensor, and we have seen the data of the camera that is being published into the ROS topic. But for most of the people, this data doesn't mean much. They are just numbers, and numbers for a camera may not be very useful. So what we can do in order to see this data in a different way. Okay, let's have a look to a new functionality in the construct that you haven't seen yet. That is the Open VPN function. This basically what does is to create a virtual private network between your local computer and the simulation that is running in the construct. So from your local computer, you can interact with the simulation. Let's do this. Let's click here and press yes. This will download a file named client.ovpn. Here we have it. Okay. Now let's go to our local computer. In this case, I have it download. Let's remove. I had a previous file, so I will be renaming this new file. Okay, and now all you have to do is just follow the instructions that appear in this modal here. So first, when we have downloaded the client.ovpn file, we'll type in our console this command here that will establish the connection between our local computer and the simulation. Let's wait some seconds till the connection is established. It's almost. Now let's open a new terminal. And here we will be typing these commands. Here. First, we will do the export of the ROS master library. We put the IP into our hosts directory. And finally, we'll do an export of host aliases. Okay, it's done. Let's do this a little bit bigger. Perfect. Now we are connected to the simulation. For example, if I type a ROS topic list here, I'm seeing all the topics that the robot is publishing. The camera, we place it in the head, the IMU data. Okay, so what can we do now? For example, so we can use a ROS package that is named image view. That basically what does is converts the numeric values that is receiving the topic to actual images. So let's do this. ROS run image view, image view, and we will give the image the value of the topic where the camera is publishing. In this case, is the image raw topic. Perfect. Here we have a new window. You can see here. Okay. So now, as you can see, we are actually seeing what the camera is seeing. For example, let's place square right here. Oh, sorry, I think the camera isn't placed in this direction. I think it's orientated to this direction. Okay. A second. Okay, I don't know why this is not showing the elements properly. Let's try again. Well, it's having some kind of okay. Well, this, as you can see, serves to see what the camera is seeing in images, not in just numbers. Okay, and another functionality we can use, in this case it's for the IMU sensor. It's the RQT plot package provided also by ROS that transforms numeric data that the IMU is giving to a 2D plot. Let's see how this works. Okay. Plot. Plot. Okay, so here you have the plot. Now we will have to introduce here the topics we want to see in this plot. In this case, we will introduce the, for example, I don't know, the angular velocity, which is velocity. It's X, Y, and Z. And let's also have a look to the linear acceleration. This will be Interesting. And as you can see now, the plot is not moving at all because the robot is static, but let's see what happens. For example, if we take the robot, we move it up, and we let it down, it will obviously gain a linear acceleration, so the plot must show something. Let's see what happens. Here we have. Let's repeat it again, in case you didn't see the plot well. And there you have. So there's suddenly an incrementation on the linear acceleration, and then again, the robot is again static, so it stops. Interesting. Okay. So let's stop. And we can also stop. And well, that's all for this webinar. You will have, of course, all the files used in this webinar available for you to use them. You can, well, let's stop the simulation. You can share with us your own creations if you want to make your BB-8 model. You can share it with us right here. Just select the number of the simulation you want to share, for example, click the share button and type here the username. We are giving a username for you to share with us your simulations in the link in the description of this webinar. Sorry, and you can link it with any user in the construct, really. So I encourage you to do it. And well, that's all for this part of the tutorial. The last part, the third part of the tutorial, will be next Friday, and it will give a nicer look to the robot. This means it will add the meshes, so the robot will look like a real BB-8, and it will also add another plugin that is a differential drive modifier in order to move both the base and the head of the robot. So it will also give mobility to the BB-8 robot. And well, that's all. I don't know if you have any questions. I think I can see if you are typing any questions, but I'm sure the people of the construct, my partners, will be glad to answer any question. Okay, so I will say goodbye to all of you. Thank you to all the viewers who have been in this webinar, and hope we see you next Friday with the last part of the webinar. Goodbye and thank you.